Now case 2 for the square matrix from order 3 by 3. We will try to obtain the inverse matrix and the cofactor matrix and the adjoint matrix as well. In this example, we will do that for the matrix 3 by 3. Then at the beginning, I should compute the determinant of that matrix. As you know, to do that, I will open big bracket with a small bracket minus big bracket with a small bracket plus big bracket with a small bracket. Then as usual, I will try to fill the small brackets first. I will put the first row, the element of the first row inside the small bracket. Then inside the first small bracket, I will put 1, and inside the second small bracket, I will put 2, and inside the third small bracket, I'm going to put what? To put 3. After that, I will go inside the big brackets and I will put minus. Here I'll put again minus, and here I'll put again minus. Then to fill the first bracket here, I should go to the first number, which is 1. Then I will go to that one and I will try to hide the row, and then I will hide the columns. How many elements will remain? Will be 4. Just make multiplication between them. 4 multiplied by 6, which is 24, and 5 when you multiply it by 0, it will give us 0. By the same way, if you would like to fill the second bracket, you should do what? You should go to the number 2 and try to hide the row and the column. How many items will remain? 4. Just make cross multiplication between them. 0 multiplied by 6, which it will become 0, and here I have 5 multiplied by 1, it will become only 5. Again, to fill the last bracket here, I should go to the digit 3 or the item 3, and I will try to remove or to hide the row and the column of 3. And still we have 4 items. You can make multiplication between them. 0 multiplied by 0, which is 0, and 4 multiplied by 1, which is 4. Now you can just simplify to obtain the number, or even you can do it by the calculator. Then 24 multiplied by 1, which it will become 24. This negative multiplied by this negative, it will become positive. And here you have 5 multiplied by 2, which it will become what? 10. And again, I have here positive multiplied by negative, which it will become negative, and 4 multiplied by 3, which it will become what? It will become 12. Then now I have what? 24, and 10 minus 12, which is negative 2. Then 24 minus 2, it will become 28. Then the determinant of the matrix A equal to 22. Hence, it's not equal to 0. Then we can compute the inverse. Then as you saw, the determinant of the matrix A, it was 22. In step number 2, I will try to make 3 matrices at the same time. Then this is the matrix 1, and this is the matrix 2, and then finally this is the matrix 3. The name of the first matrix, the minors matrix, and the name of the second matrix, the cofactor matrix, and the name of the third matrix, which is the adjoint matrix. To compute the minors matrix, I should go to each element here and I'll try to compute his minor. How to do that? I will go to the first number, which is 1, and I will remove the row, and then I will remove the column, and I will make cross multiplication. 4 multiplied by 6, 24, minus 5 multiplied by 0, which is 0. Then the answer will become 24. Then at the place of 1, I'm going to put 24. Now let's compute the minor of number 2. Then you should remove the row and the column of number 2 and make cross multiplication. 0 multiplied by 6, it will become 0, minus 5 multiplied by 1, it will become negative 5. Then the subtraction here will give us negative 5. Then at the place of 2, I will put negative 5. To compute the minor of number 3, I will remove the row and the column of number 3, and then I will make cross multiplication. 0 multiplied by 0, 0, and 4 multiplied by 1, negative 4. Then 0 minus 4, it will become negative 4. Then at the place of 3, I will put negative 4. Now we have completed the first row. Let's start now with the second row. I will start with 0. What I will do with that 0, I will remove the column and the row of 0, and then make cross multiplication between the remain. 2 multiplied by 6, 12, minus 3 multiplied by 0, which is 0. 12 minus 0, just 12. Then at the place of 0, I'm going to put 12. Now let's compute the minor of number 4. Then I will go to number 4 and I will remove the row and the columns and start to make multiplication. 1 multiplied by 6, just 6, minus 3 multiplied by 1, which is 3. 6 minus 3, it will give us 3. That's mean at the place of 4, I'm going to put 3. Now let's compute the minor of number 5. Then try to hide the row and the column. And start. 1 multiplied by 0, just 0. And 2 multiplied by 1, which is 2. Then 0 minus 2, negative 2. That's mean at the place of 5, I'm going to put negative 2. Now we have completed the second row. Let's move to the third row. Then I will go to number 1 and I will try to compute the minor. Then 2 multiplied by 5, which is 10, minus 3 multiplied by 4, which is 12. 10 minus 12, negative 2. That's mean here I will put negative 2. To compute the minor of the number 0, just hide the row and the column and start to make multiplication. 1 multiplied by 5, 5, and 3 multiplied by 0, 0. 5 minus 0, it will become only 5. Then here you can put 5. Here is the last minor with us, which is related to 6. Then I will remove the row and the column of 6, and then I will make multiplication. 1 by 4, just 4, and 2 by 0, it will give me 0. Then the answer will be 4. Then the cofactor of 6, just 4. From the minors matrix, you can obtain directly the cofactor matrix. How that? I will go to those numbers. I hope you can see them. This one, and this one, and this one, and this one. And I will change their sign. And I will keep the remain as they are. Then 24, I will keep it as it is. It was here negative 5, change the sign, it will become positive 5. Negative 4, I will keep it as it is. And then down, I have 12, I will change the sign, it will become negative 12. 3, I will leave it as it is. And here I have negative 2, change the sign, it will become positive 2. Down here I have negative 2, I will keep it negative 2. And I will change the sign of 5, which it will become negative 5. And what about 4? 4, I will keep it as it is. Then now I have with me the cofactor matrix. Then remember, I will change only the sign of those numbers. This one, and this one, and this one, and this one. Anyway, hence you have the cofactor matrix. You can obtain from that the adjoint matrix. How to do that? Just by the transpose. Then I will take the first row from here, and I will convert it there to be the first column. Then here I have what? I have 24 and 5 and then negative 4. Take now the second line and make it there the second column. Then negative 12 and 3 and 2. And again take the last line and make it there the last column, which is negative 2 and the negative 5 and 4. Then here I have completed even the adjoint matrix. Then, as you saw before, from the matrix A, we have obtained the determinant of the matrix A, and it was 22. And for the matrix A, we have obtained the A adjoint, and it was. Then, to obtain the A inverse, this is equal to the rule of the inverse 1 by the determinant A multiplied by the A adjoint. Then I will substitute now. Then the A inverse equal to 1 by the determinant A, this part we know it, 22. And instead of the adjoint, I will put the value of that adjoint matrix, which is 24 and 5 and negative 4. And here negative 12, 3 and 2, and negative 2 and negative 5 and then 4. Now if you would like, you can multiply this number, which is 1 by 22, inside the matrix. Then I should multiply it by all the elements. Then it will become like this. When you multiply 1 by 22 by 24, it will become like that, 24 by 22. Again, multiply 1 by 22 by 5, then it will become 5 by 22. And then negative 4 by 22. And then negative 12 by 22. And 3 by 22. And then 2 by 22. And then negative 2 by 22. And then negative 5 by 22. And then 4 by 22. And you can make some cancellation if you would like. Then here now I have with me the inverse matrix for the case 3 by 3. Now in the homework 2, you have matrix A from the order 3 by 3 and another matrix B from the order 3 by 3 as well. And I would like you to compute here the A inverse and A multiplied by B inverse, and then try to compute also the B inverse multiplied by the A inverse and the A plus B inverse and B multiplied by B inverse, and in number 5 here the B transpose inverse, and then in number 6 the opposite, the B inverse transpose. Then here I will compute the transpose first, and then I will compute the inverse second. But in number 6, the opposite. I will first compute the inverse, and then at the end I will take the transpose.